Previously, we were looking at the graphs in which we considered the uniform motion, uniformly accelerated motion, and uniformly retarded motion. We looked at the equations and corresponding graphs. Now, in the uniform acceleration case, we have a special condition, that is the third case, and this is about uniformly retarded and then accelerated motion in opposite direction. So this is a special case, like initially there is retarded motion, that is deceleration, and deceleration causes velocity to become zero. Once it becomes zero, then the object gets accelerated and moves in the opposite direction. So this is a very good example when something is projected upwards, straight upwards from ground. So first it is retarded when it moves upwards. Okay, so anyway, we know that the upward direction is considered to be the positive direction. Throughout the motion, its acceleration is downwards and it is a constant, right? So the acceleration is constant because it is acceleration due to gravity. So downward acceleration is considered as negative, right? Then let us assume that air resistance we neglect. When the air resistance is neglected, the speed of the particle at which it at the time of projection is equal to the speed at which it is striking the ground, right? From ground level we throw something upwards. Whatever is the velocity with which you throw it up, it's the same velocity with which it's going to hit the ground when it comes back. So and the another condition is that the velocities are equal but opposite in direction, right? This is the whole idea about this kind of motion, right? Uniformly retarded and then accelerated, right? Let's try to look at the various aspects of this kind of motion. So let's start with an example. Example of this kind of motion is a particle projected upwards, right? So upwards, let's consider that as a positive direction. So at a highest point in under this condition, this is the example, and under this kind of motion we know that at the highest point velocity is zero, right? At the highest point velocity becomes equal to zero, right? And it is going to come down, so you are going to see that the acceleration is going to be positive. Sorry, it's going to be negative because it is downwards, right? At the highest point, it is going to be zero. So velocity was upwards, then the velocity becomes downwards, and you see there is a change of direction of motion, right? Then acceleration is a constant. it is constant, and it is downward. Right. So which means it is negative for us, right? So anyway, the sign convention, we follow the same thing what we were using so far. Right. And the air resistance we always try to neglect, and this is initial velocity, right, is equal to the final velocity. So initial velocity is the velocity at the moment when we throw it upwards, and the final velocity is the velocity with which it's going to strike ground. Right. Now, so velocities will be same, but they are opposite in direction. Right. This is the basic feature of this kind of motion. Okay, moving further. During the acceleration, velocity is downwards, therefore negative, and it is going to increase. Right. So when it is moving upwards, there is a deceleration, right? A retarded motion. But when it is moving downwards, there is acceleration. So velocity is downwards and it will increase. Upward journey time is equal to downward journey time. This is because of this condition. Since the initial and final velocities are same, initial velocity is something like it starts from highest velocity and reaches zero during the upward motion, and time taken for that will be equal to the time taken to come down. All right. So that is the next feature, the upward journey time is equal to the downward journey time. So upward journey time becomes equal to the downward journey time. Sorry. Finally, the sorry. Uh, Finally, the particle returns to the ground. Therefore, total displacement, if you are calculating, the displacement is going to be zero. It is because, right, wherever the object started, object comes back to the same distance. So displacement is total displacement. The final displacement will be zero, right? But in case of upward journey, displacement increases, right? And during the downward journey, the displacement decreases. But displacement from the starting point is positive, right? So what we expect now, the displacement versus time graph, right, is going to be, it has to show the same thing, right? So displacement versus time will show you the same characteristic. Initially, displacement is zero, it increases, right, and then it decreases, right? This is what I need to show. I have to show when I draw the ST graph, right? But definitely the velocity can be simply calculated by using the slope of the ST graph, right? So anyway, we'll draw the what you call the graphs right away, right? So let's go to the graphs of this kind of motion, right? So we don't want the equation because already every equation is written. First part will take care of the decreasing velocity, right? Decreasing negative acceleration and decreasing velocity, that is something like this. And then we have increasing part, that's a positive. So we have to club both of them together to get the results over here. Okay, so the first graph I want to draw is the acceleration graph, right? Under the above mentioned conditions, acceleration is always negative. So the first graph looks like this one. So the first graph, we'll draw the x-axis, this. So this is time versus acceleration. So acceleration is negative, always it's going to be a negative value. So let's write this is a negative value of the acceleration throughout the given time axis. So let's say if this is the acceleration due to gravity, then this has to be a constant value minus of 9.8 meter per second square. Okay, let's mark some points, say A and B for our reference, right? So the midpoint, let's say this is a time. Let's say this throughout is a journey of the object. Let's say somewhere at the middle, I have a point A, and somewhere here, this is the last point, that is a B. So the object is actually moving starting from point A till point B in the time axis. So A could be 1 second, B could be 2 seconds, like that. Okay. Now let's draw the second graph, and here we will try to plot the velocity versus time. All right, let's plot the this should be the velocity versus time. So I'm going to plot time here, and this is the velocity v of that particle. All right, now I know that initially I throw with some velocity, it's going upward, so positive. But because of the negative acceleration, it keeps on reducing. It reaches zero. So I have to start from a point, say I will start from a point somewhere here. Okay, it keeps on reducing. So it starts from this point, keeps on reducing at a particular time A, and at time B, it has to reach the opposite side because it's going to be negative. So let's say this is initial velocity u, and final velocity will be minus u because object reaches the peak position at time t equal to a, and it comes back to ground at time t equal to b, and during the time it hits ground, the velocity's magnitude should remain same. That's why you see this u should be matched on the opposite side with the minus u sign. Okay, so the velocities are same, but they are in the direction. Okay, this is our observation, and let's come to the third graph. And in the third graph, our intention is to plot the distance, or sorry, displacement versus time. All right, so let us say this is the time axis, this is the displacement s of the object. So as we know now, as I throw an object straight upwards from ground, right, the displacement keeps on increasing. It reaches a maximum point, that is the highest point of displacement. That highest point is around A for us. So when you reach A, the displacement is highest. Okay, and when you reach B once again, the displacement should become zero because it reaches the same point from where it started. So the displacement curve should be something like you start from this point, you go to the peak point, and then you come back, right? Something like this. It's expected for a parabola, right? So slowly increases, reaches a maximum point, because at the maximum point you can see that the slope is zero. So when the slope is zero, that means the velocity is zero. At the peak point, when we throw something, velocity becomes zero. That's why it is indicated like this, right? Slope of this curve, initial slope is the initial velocity, that is u. How to find that? Slope at the zero, right? If you find a slope here, that is the initial velocity. but the ds by dt at any point you can find what is the velocity. Okay, right. So from these three graphs, the points that the points we can understand, we can try to find out from these three graphs are as follows. So first one is I note that the acceleration is minus 9.8 meter per second square. So if the motion is taking place under gravity, then this A is standard, right? For problem's sake, you can take it as minus 10 as well, no problem. Okay, so this means under gravity the value is minus 9.8, but if you are considering something else, then you have some value which is negative. Right, let me assume that in all the cases O is the starting point, right? So initially you have the velocity equal to plus u. That is because, right, the velocity is positive and it is going in upward direction, so that is a positive quantity. So you see that the velocity is positive. Right, this is the initial velocity, right? And this can also be found, this plus u can be also be found using the slope of this curve, right? At the initial point you find the slope, you get that, right? Fine. Then A is the highest point. At t equal to A, object reaches its highest point, right? So at that point you can see if in the velocity graph, it the velocity at point A reaches 0. At the same time, I can note the same thing even here, right? If you find the slope, I understand that the slope becomes equal to 0 here, right? So it matches. V will be 0. The slope of the S curve will be 0, right? So like that, we can justify that at the point A, object reaches its highest point. Then B is the point when the particle is going to strike the ground once again. And the slope, if you try to find the slope of this is again in the velocity curve, it reaches minus u. I have to justify that. If you look at the slope, this slope is actually a negative slope. Okay, so if you find the slope at this point for the given curve, it's going to be negative. So negative of u will be the answer. So that actually justifies this value as well, right? And if you try to measure the displacement, right, the displacement was 0 initially, and even at B, the total displacement shows as 0. The next thing, uh, in every graph, you can see that the distance, the time taken to cover OA is same as time taken to cover OB, right? So that means time of ascent is equal to time of descent. So that can also be observed in every graph. So each and every graph will show you OA is equal to AB. So the time is time of upward journey is equal to time of the downward journey. So in the upward motion, that is from O to A, velocity is positive, but it decreases. You see, velocity is positive but decreases. Right. And between A to B, velocity is negative and it increases. Right. I can see that it is increasing in the negative direction. So that's what. So slope of the ST graph is always negative, right? Because of these conditions. Okay. Right. Next point. Okay, let's solve some problems based on this concept. This is the next question. Okay, the velocity of the particle at t equal to 0 is 2 meter per second. Right? So the question is to find the velocity at the end of the 4th second, right? And this is the given curve. So this is 0. This is 2. And this is 4. And this is the time in seconds. And this is the acceleration curve. Okay, this is AT. Right. Now, the given data is a acceleration curve. Now, if you look at the acceleration versus time curve, and in order to find the velocity, right, what I'm supposed to do, I have to use this table, right? See here, acceleration time graph is given, right? If you try to find the slope, that is the rate of change of acceleration. If you find the area, that is, right, v. I have to find the area. So how to find the area? Area means it is integration. Okay, so let me write another point. Let me add a point to this graph itself. Okay, so here the slope is actually differentiation, d by dt. Area is nothing but integral dt. So if you do the integration, that is the area. If you do the differentiation, that is the slope. Okay, so now it's very clear from this. If you want to calculate the velocity, then I am supposed to perform the integral dv, right? So that is, so the solution is integral dv is equal to, right, integral, that is a into dt, right? So integral dv will give you, right, the difference in the velocities, that is v final. V final is v4 minus v initial is v0 is equal to the area of this triangle, right? What is the equation to find the area of the triangle? Right, I'll write a sentence before this so that what we are trying to do, it becomes clear. Okay, let me slightly move this down. Before that, so the meaning of this equation, what we have written, integral dv is equal to integral a dt. That means, right, left hand side, the meaning of the left hand side is the okay, the change in the velocity is equal to the area under AT, that is acceleration versus time curve. So what do you mean by change in velocity? The final velocity minus initial velocity. What is the final value? That is at time equal to 4, whatever is the value of the velocity. That is the final velocity. What is the initial value? Initial value can be found from this, right? So that is time t is equal to 0. At time t equal to 0, whatever was the velocity, we call it as the initial velocity. So normally we write v final minus v initial, but since I know when the final is happening and when the initial value is happening, so I can directly write v4 minus v0. So v4 minus v0 should be equal to area of this curve. Again, I can see that this area refers to the area of the triangle, right? Simply calculate the area of triangle. We know the standard equation to calculate the area of a triangle, that is half base into height. So they have given a value like this. This is given. Okay, so the height is required. So in this case, they have given this is given as 4. All right. So what is the total area? Half into this is the base, right? Base is 0 to 4. So base is 4. And I need to know what is the height. Height is this one. Again, that is 0 to 4. So the answer is half into 4 into 4. Right. So that means V4 minus V0 is equal to 8. So you want to calculate velocity at the end of 4 seconds, that is 8 plus V0. V0 is given. If you see, the particle at t equal to 0 is 2 meter per second, right? Which means that is a V0. So since V0 is given, I can simply write this as this is equal to 2, not 2, sorry, 8 plus 2, I guess. Because 8 is the current value and 2 is the other one. So this is 8 plus 2 equal to 10 meters per second is the answer. So using this, we can calculate the velocity. Okay, the next next question. Okay. A particle is projected upwards with velocity of 40 meters per second. All right. Plot AT, BT, and ST graphs taking G is equal to 10 meter per second square, right? So they're asking they're asking us to plot, right, all the 3 graphs. So anyway, the shapes are very well known to us, but only the values are supposed to be found. Okay, so if they under this kind of motion, whenever you throw something upwards, uh, the journey time can be calculated like this. So that is upward journey time equal to it's also equal to the downward journey time. So we'll calculate using u by g. So u is given as 40 and g is given approximated to 10. So you see 4 seconds. Upward journey equal to 4 seconds. This implies even the downward journey is going to be 4 seconds, because we already have discussed about this upward journey time equal to the downward journey time. First point. Then I need to calculate the total journey time, right? So total journey time equal to 8 seconds. This is simply because 4 plus 4. Alright, then I can also calculate what is the maximum height attained by a particle, right? So again, we have a formula, that is maximum height is equal to, the formula to calculate the maximum height attained by that particle is u square divided by 2g. Alright, u square is 40 square initial into 2 into 10. So 40 square, 1600 divided by 20 is 80 meters. Right. So the first point is that, so directly we can go for a graph. I will draw the AT graph. Right. AT graph, I know that acceleration is constant and it is negative, right? Because acceleration is always towards ground and anything downwards is negative, right? Now I don't write simply A and T. I know that what is the value of A and till what time this is going to act, right? Since we know both these values, right, we are supposed to draw the graph with accurate values. So for example, let me draw the graph. So this is the time, this is acceleration, and the current for this given problem, it's going to be a constant value and it remains constant for certain duration. So what I need to mention specifically here is, what is this value? This value will be -10. And till what duration, up to what time this is going to act, right? That also I need to be specific. So this is 8 seconds, right? So this is the exact graph of the particle's motion in this problem. This is the first graph. And for the second graph I'm going to draw is the velocity versus time. So the second graph should be VT graph. So VT graph, I know that object is moving upwards. You are throwing it with a initial velocity of 40 meters per second. So it travels upwards for 4 seconds and reaches a velocity equal to 0. Then it starts to move downwards and reaches ground with a velocity of -40, because initially you threw with 40, it comes back and hits the ground with the -40. So because of that, I am supposed to draw a graph that looks like this. So totally the journey is once again 8 seconds. So let's divide this into, this is 0 seconds. Somewhere here I draw the 4 seconds, and somewhere here let's have the 8 seconds. So if I say this is the point where it has +40, and let's say this is the value for -40, it has to reach -40 at this point, right? Initially it will start from that point, it will reach the -40 over here, right? For that reason, let's try to draw the curve. Filters like this. So you see it actually starts at -40, reaches -40 at time t equal to 8 seconds, and this is the time axis and this is the velocity, right? So you are clearly showing that it started initial velocity of +40, travels 4 seconds, velocity becomes equal to 0, travels 4 more seconds, so total time duration is 8 seconds, and the velocity becomes -40. This is the VT graph. All right, moving further, the next concept or next graph I'm going to draw should be the ST graph. Okay, so when we write the ST graph, I have to show the distance it traveled versus time. So we already have calculated the maximum distance, right? Maximum displacement, that is 80 meters. So the highest point that the object reaches is 80 points. Initially 80 meters, sorry. Initially it starts with when we start the graph, it starts with a height of 0. So this is time versus displacement. So let's say this is 0, and at the middle I have 4 seconds, and at the end I have 8 seconds. So at 4 it has to reach a highest point. Let's see, this is the highest point that the object reaches, and let's say this is 80 meters, right? That's S. So the graph that I'm going to draw should start from 0, okay, and it should reach this point, and then it comes back, and it's going to reach 0 over here. So it's like a parable, right? So start from 0, reaches a maximum of 80 meters, and then comes back. So this is what is the required curve. All right, let's move further. We'll solve for another problem based on the graphs. The acceleration time graph of a particle motion is given below. Find its velocity time graph. If v equal to 0, when t equal to 0. In the sense, initial velocity is given as 0. Okay, so they already have given a graph, and this graph, this is the given graph, and this is the acceleration versus time graph. And vertically we have 2, 4, minus 2, minus 4. Initially the velocity starts like this. So it starts at 2 and goes till 2. And then the velocity, sorry, the acceleration becomes equal to 0. So we have vertically coming down to 0, and starting from 0 till 4 goes like this. Then from 4 to 6 it comes down to -4. Okay, then it comes back to this. So the time axis values are given. This is 1, 2, 3, 4, 5, 6 time in seconds, and this is the acceleration in meter per second square. Right. So you can see that the initial velocity is 0. So v0 when t is 0 means, I know that from the given data I come to that when time is 0 there is no velocity. So initial velocity, right, u is equal to 0. Okay, when u is equal to 0, and I also note that velocity is acceleration is a constant value. Acceleration is not changing. So this belongs to a specific case where this one you can see here. This means if u is 0, right, I'll use this particular notation. If u is 0, velocity is equal to at. So velocity is at means u0 and velocity is at will be like this. So I'm supposed to draw this kind of graph, right? So initially there is no value of velocity, and velocity increases with time as this equation. So let's do the calculation and then we'll write the graph at a later stage. Okay. So this means, so initial velocity u is 0, right? And from t is equal to 0 till t is equal to 2, right, the velocity is equal to at, right? That is, a is, you can see the graph, it says acceleration is equal to 2, right? U is equal to 0. I'll write a is equal to 2. So this is 2t, right? So t equal to 0 means final velocity is also 0 because 2 into 0. But at t is equal to 2, what is the velocity? 2 into time is also 2, so this is equal to 4. So we have 4 meter per second square. 4 meter per second, that's the velocity. Anyway, okay, so this is what I need to plot. Starting from 0 till 2, right, the velocity will be linearly increasing, and at t is equal to 2, velocity reaches a specific value. That value is equal to 4. All right, okay, let's start drawing that graph here. Let's see. Let's try to draw that. So I want to plot graph here. Okay, so let's say this is 0, 1, 2, 3, 4, 5, and 6. Okay. So we will draw the exact same points like that's given in the input graph. That's the acceleration graph. 1, 2, 3, 4, 5, 6 seconds. So totally we have 6 seconds. This is the time value. Now I know that starting from 0 till 2 seconds, this is what is going to happen. Okay, this is 1, 2, 3, say this is 4. So 4, this is the velocity. So at time 2, it has to reach this point. Okay, so time 2, it is reaching this point, and it is linearly increasing. All right, so my velocity graph will start at 0 and it goes till here in this fashion. This is what we have calculated so far. Okay, now at the end of 2 seconds, velocity is 4 meter per second. Okay, now let's move to the second part of the given data, that is from 2 till 4, there is no acceleration, right? Acceleration is not there. When acceleration is not there, this falls under a different condition. What is that condition? It falls under the first case, uniform motion. You see, acceleration is 0. Velocity will become constant, that's all, right? Whatever is the velocity, it will be held. The same value will remain over there. First, let me write the point, then we'll come back. Okay, so the next one is, so okay, I'll write below. So this is from t is equal to 2 till t is equal to 4 seconds, the acceleration becomes equal to 0. How do you know that? It's from the given graph. You can see that 2 to 4, the value of acceleration a is equal to 0. So when a equal to 0, right, velocity is a constant, right? So velocity is constant and its value will be the value of velocity at t equal to 2. At t equal to 2, just now we calculated it is equal to 4. So velocity will remain constant, that is 4 meter per second from 2 till 4. So where is 4? 4 is here. So till here this is going to be a constant. So let's connect it. So it is 4 and it will remain 4 from here till here. Okay, that is done. So at t is equal to 2 and till t is equal to 4. Okay, now let's move to the third part of the graph. And the third part of the graph says velocity, sorry, not velocity, acceleration is minus 4 from 4 till 6, right? Starting from 4 till 6. So what happens? What is the equation? Now you see this falls under another condition, completely different condition. That is uniformly, it is a retarded motion, right? It's a retarded motion. Acceleration is negative and velocity becomes this equation. Velocity is u minus e. Okay, this is what is happening. So next one, that is from t is equal to 4 to t equal to 6, the acceleration is equal to minus 4 meter per second square. So this means, right, I use the appropriate equation, right, by looking at what condition it is. It is v is equal to u minus at. Right. Now this motion begins, initial value of the velocity is what? 4. So for this case, you see here, this kind of motion begins at 4, but for my calculation, the time is 0. So this is like time 0, this is time 1, this is 2. The time is equal to 2 because the motion begins at this point, right? So relative timing has to be considered. So it's not like that particular motion starts at 0 and goes till 6 seconds. It's not. It starts at 4, ends at 6. So the time has to be considered as only 2 seconds. Okay. So at the end of 2 seconds, what is the value of velocity? I need to know. So in this case, u is equal to how much? The initial velocity is plus 4. Okay. And the time of this motion is 2 seconds because starting from 4, it will move only till 6 seconds. So 4, 5 and 6. So 2 seconds. So the final velocity of this at the end of 6th second is equal to, this is 4 minus right? I'm going to put acceleration is 4. This is already a is minus 4, so I don't have to change it. Don't make it as minus of minus 4. So into 2 seconds. Okay, so 4 into 2 is 8. That's minus 8 plus 4 is minus 4, right? Meter per second. So this is at the end of 6th second, the velocity will be minus 4. If that is, this is 1, this is 2, this is 3, and if I say this is minus 4, right, this value should be, it should reach at the end of 6 seconds, right? So this is what the graph looks like. So at the end of 6 seconds, I should be able to show that this is minus 4. Right. So we could convert the given acceleration time graph into the velocity time graph. So I just have to understand what is the condition, right? What particular type of motion it is, and I should be able to convert the given data into the other data using the table which we have written earlier. Okay, right. Then let's move further. Okay, as I can see, the graphs are over here. Okay, so let's then stop here itself so that we can move on to the next topic in the upcoming class.